Kiddos, welcome back. As promised, today we're going to talk about saturated, unsaturated, and supersaturated solutions. That last term sounds made up, doesn't it? Supersaturated? It's not. It's a real thing. And there's a nice little demonstration video that you'll need to watch in conjunction with this lecture video that will illustrate this. And it's one of my favorite demonstrations, and I think you'll like it too. So make sure you watch the demonstration video that I have on my channel. It's entitled, of course, Supersaturated Solution. Okay? All right, so let's define the terms quickly. A saturated solution is a solution where the solvent has dissolved as much solute as possible, and I'm going to add at a given temperature. You're going to see later in this video that temperature does play a role in the solubility of a solute in a solvent. So a saturated solution means the solvent has dissolved as much solute as possible at a particular temperature. It can't dissolve any more. It's maxed out. Okay? Unsaturated, of course, is a situation where the solvent has not yet dissolved as much solute as possible at a given temperature. So we haven't gotten there yet. We can still dissolve more solute in that solvent, so it's considered unsaturated. Here, let's take a look at the graph below, and let's pick on, I don't know, how about potassium nitrate? This curve right there. You guys see it? All right. Let's take room temperature, and we're going to pretend room temperature is about 20 degrees. So at 20 degrees Celsius, it looks like 100 grams of water can dissolve, I'm going to say about 35 grams of potassium nitrate. So about 35 grams of potassium nitrate can dissolve in 100 grams of water at 20 degrees Celsius. Okay, can you guys agree it's about 35? All right, so that means if I added 35 grams of potassium nitrate to 100 grams of water, I couldn't dissolve any more. I would have a saturated solution. But what if I only added 17 grams? Yeah, I could still dissolve more, so then that situation would be unsaturated. What if I warmed this solution that's at 20 degrees Celsius up to 50 degrees Celsius? So all I've done is I've taken this solution here, I've put it on a hot plate, and I've warmed it up to 50 Celsius. Now, isn't it possible to dissolve close to 80 grams of potassium nitrate? So about 80 grams of potassium nitrate can dissolve in 100 grams of water at 50 degrees Celsius. So if I only had my 35 grams in there, and I warmed it up to 50, wouldn't it turn from a saturated solution to an unsaturated solution? Generally speaking, the solubility of solids increase with an increase in temperature. Take a look at the curves on this graph. As I warm up my solvent, I can dissolve more of my solid solute. And that's true for just about all solids. They dissolve better in a warmer or hotter solvent. So it would be saturated at 20 degrees Celsius if I had 35 grams of potassium nitrate in 100 grams of water. But if I warmed it up to 50 degrees Celsius and I had 35 grams in there, it would be unsaturated because I can actually hold 80 grams at 50 Celsius. So let's go ahead and dump in enough to make it 80 grams. So now I'm here at 50 degrees Celsius, and I have 80 grams of potassium nitrate in my water. Got it? It's now saturated. Okay, what if I cooled my water down? What if I cooled it back down to 20 degrees Celsius? I wouldn't be able to dissolve all 80 grams. I can only dissolve 35 grams. So the difference would end up precipitating out. It would crystallize out. And in this case, 80 grams I could dissolve at 50 degrees Celsius. If I cooled it down to 20 degrees Celsius, I could only dissolve 35 grams, so that's a difference of 45 grams would crystallize out. It would not be able to stay dissolved. It would precipitate out. Got it? Because at 20 Celsius, I can only hold 35 grams of potassium nitrate in 100 grams of water. Well, that brings us to our next vocabulary term. It is possible to form, in certain situations, supersaturated solutions. And in these solutions, the solvent has dissolved more solute than normally possible at a given temperature. I've dissolved more than I normally can. Well, how could you do that? Well, when you watch the demonstration video, you'll see how I do it. But what I'm essentially doing is I am forming a solution at a higher temperature that's saturated. So let's say I dissolved 80 grams of potassium nitrate in 100 grams of water at 50 Celsius. There are some solutions that when you cool them back down, instead of the excess crystallizing or precipitating out, they stay dissolved. And so you have more than you normally can have at that temperature. And so since you have more than you normally can have, we call that supersaturated. These tend to be fairly unstable in that if you shake them or agitate them in any way, if you place the beaker that's holding that supersaturated solution on the countertop firmly, the vibrations might be enough to cause it to go from its supersaturated state back to its saturated state, and a bunch of crystals form really, really quickly. And that's why it's sort of kind of fun to watch. So watch the demo related to this, and I think you'll have a better appreciation for what supersaturated means. Now, we already talked about the effect of temperature on solubility. Generally speaking, solids dissolve better at higher temperatures. So, what happens to the solubility of most solids when temperature is increased? Most solids' solubility will increase. Most solids dissolve better at higher solvent temperatures. Now, that's not necessarily true for gases. And this is the last thing I want to show you today on this particular video. So we'll just end with this quick discussion. So if you take a look at this graph, these are all gases. And this is what we're going to start with on our next video. Notice what happens as temperature increases to the solubility of different gases. Do you notice they decrease? Yeah, that's sort of interesting. So solids dissolve better at high solvent temperatures. Gases don't dissolve as well at high solvent temperatures. They dissolve better at colder solvent temperatures. And we'll talk about that soon. All right, that's good enough for now. Bye-bye.